Okay, ready for this?
Always.
So we're diving into this paper.
Hmm.
And it says that, get this
Yes.
information, like the stuff in our emails
Right?
might actually be like the fundamental building block of reality.
Wow.
Not just like a building block,
Yeah.
but the building block. Like,
Everything.
yeah, we're talking about gravity,
Mm-hmm.
energy, even time,
Yeah.
all shaped by
Is this
information. Like, seriously.
It's a wild idea.
Isn't it crazy?
It is, but
Yeah.
this paper's fascinating
Okay.
because it doesn't just like throw out this crazy idea.
Wow.
It gives us equations.
Ooh, equation.
Yeah, information gravity energy equations. Or IGE, they call them.
IGE, okay.
And these equations could
Yeah.
completely change, revolutionize our understanding of physics.
Okay, got to be honest.
Hmm.
When I first saw IGE equations,
Yeah,
my eyes kind of glazed over a little.
I get it.
Yeah.
But then I read about the potential tech.
We're talking anti-gravity, faster than light travel,
Whoa.
zero fuel energy.
And suddenly I was a lot more interested in those equations.
Right. They grab your attention.
Yeah, it's like, okay, science fiction, but that's kind of why we're here,
Exactly.
right? To like take these
Complicated.
really complex ideas and make them,
Understandable.
yeah, look at what are they predicting?
The predictions.
Yeah, and how are they going to test this?
The experiments, right?
Yeah, a whole new framework.
Exactly.
All right, so let's start with like the
Like the
core
countdown.
idea,
Yeah.
information density. They're saying that information isn't just this like abstract thing.
It's got
Has a density, like
Yeah.
how crowded a room is.
Yeah.
That's a good analogy.
It is, right?
Yeah, think about like trying to
Move through a room.
move through a packed room
Yeah.
versus like
An empty one?
an empty one. So
Yeah.
that crowded room
The crowded room, yeah.
has a higher information density,
Okay.
and it's almost like
It's like there's a force pushing back on you
making it harder to
move.
yeah, exactly.
So the denser the information,
Mhm.
the stronger the effect
on everything.
everything.
That's the idea.
Wow.
And then they go even further,
Okay.
suggesting that areas where there's like extremely high information density
Yeah.
could warp space-time
Wow.
and create gravity.
So gravity is not just about mass, but about
The concentration.
the concentration of information.
That's
That's
a big idea.
a lot to wrap my head around.
It is, and that's just the beginning.
Yeah.
The paper lays out this whole roadmap, the future of like physics and engineering.
Okay, roadmap time.
All right.
What kind of breakthroughs?
So they're predicting breakthroughs in like 3 phases.
3 phases, okay.
So phase 1, they predict it within the next 5 years.
5 years, okay.
And they suggest we could start seeing small-scale anomalies in lab experiments.
Oh, like?
Imagine objects
Mhm.
that appear to weigh slightly less
Okay.
in these like localized fields.
So like tiny...
On like a tiny controlled like
Anti-gravity.
the gravity effect, yeah.
Wait, so they think we could create
They think it's possible.
like mini anti-gravity fields in a lab?
In a lab, and soon,
Dude.
within 5 years.
Wow.
They also predict we might detect
Okay.
spontaneous bursts of energy in quantum systems,
Right, yeah.
almost as if information itself is being converted into energy.
Okay, I really need to hear about this roadmap now.
All right, you ready for phases 2 and 3?
I am, yeah.
Okay, so phase 2, this is in the 5 to 10 year range.
Okay.
Gets even wilder.
Wilder.
Okay, imagine creating like structured fields of entangled particles.
Entangled particles. Now, for those of us who didn't major in
Right, not everyone's
quantum physics,
quantum physicist.
can we, like, ELI 5?
Yeah, of course.
What's entanglement?
So imagine 2 coins flipped at the same time, and they always land on opposite sides. One heads, one tails,
Yeah.
no matter how far apart they are.
Okay.
That's kind of like entanglement.
So they're like...
These particles are linked in a way that defies our normal understanding of...
Space and time.
Yeah, space and time.
Okay. So it's
You see
helpful.
it.
So they're saying
They're proposing that
we could use these, like,
entangled particles to control gravity.
control gravity.
They think so, yeah.
Seriously.
We could potentially see the first tests of what they call non-local inertia modulation.
I'm going to need you to break that down.
Yeah, basically changing the inertia of an object without physically touching it.
So like moving things with our minds.
Not quite telekinesis, but
yeah.
similar principle.
Like
it's about using information to influence matter.
At a distance.
At a distance, yeah.
This is already blowing my mind.
Yeah.
And we haven't even
gotten to phase 3.
Phase 3.
This is where it gets really exciting.
Right, hit me.
10 to 25 years down the line.
Okay.
Phase 3 is practical anti-gravity.
Ooh.
Like levitation, propulsion.
Seriously.
And even, get this, prototype quantum space-time engines.
Quantum space-time engines.
Yeah.
It sounds like
Star Trek.
Star Trek, exactly.
Right.
But you're saying
it's going to be real.
Based on
this new understanding of information.
That information is fundamental.
Not just a byproduct. It's an active force that shapes reality.
Okay, before we go any further, I got to know.
Yeah.
How are they going to test this?
Right. Good question.
Because this all sounds...
It sounds amazing, but...
Yeah, it's a lot.
You need proof.
Yeah, like how do you even...
How do you test this?
Test this, yeah.
So they actually propose three experiments.
Okay, let's hear it.
To validate their claims.
Some proof to go with the...
With the mind-bending theory.
Yeah, the mind-bending theory, right?
So the first experiment aims to test if the speed...
The speed of...
Of entanglement can be affected by... Information density.
Information density, okay.
Remember those 2 coins?
Yeah, yeah.
What if the communication between them could be sped up or slowed down, depending on the, information environment?
The information environment, okay. So they're going to measure how fast entangled particles.
How fast they talk to each other.
Okay, talk to each other.
Right.
In different...
Information environments.
Information environments, okay. But how do you... even create
a high information density.
A high information density
environment, yeah.
In a lab.
So they propose using things like structured electromagnetic fields or supercooled atomic lattices to create those dense information zones.
Information zones, okay. And then they compare that to how entangled particles behave in a vacuum.
In a vacuum,
right.
Which has
very low
information density.
Right.
And if those particles start
syncing up faster, yeah,
in those information-rich zones.
Actually, that would support the theory.
It
would suggest that information itself can influence those seemingly fundamental speed limits of reality, the speed of light.
The speed of light. Wow.
Yeah. So that's one experiment.
What about the other 2?
All right. Number 2. Focuses on gravity.
They
want to see if they can create gravitational effects just by changing the information density without adding any actual mass.
So, warping space-time.
Yeah, think of it like that, with pure information.
Pure information, it sounds crazy.
That sounds even more...
Than faster than light.
Than faster than light communication.
I know, but they have a plan.
Okay.
They want to use a super sensitive gravimeter to measure tiny
gravitational shifts
in a controlled environment.
In a controlled environment, right?
And they would compare the readings before and after.
Before and after, okay.
Introducing what they call a high coherence quantum field.
What's that?
It's
basically
a lot of densely packed information.
Densely packed information. Okay.
Yeah.
And how would they create this pocket of information?
They're proposing what they call a structured entanglement lattice.
A structured entanglement lattice.
Yeah. Imagine a carefully arranged grid of entangled particles. Maximizing the information density.
In that area.
Yeah.
So tiny super organized structure of entangled particles.
And they want to see if it creates a measurable gravitational pull.
Even though there's
no extra mass.
No extra mass. Wow.
Yeah, if they detect a gravity shift, that would be huge.
It would be huge.
It would be a huge piece of evidence that space-time curvature is directly linked to information density gradients.
Okay, all right. I'm on the edge of my seat.
Okay, ready for experiment 3.
Hit me with experiment 3.
This one's the most ambitious.
Okay.
They want to create an information battery.
An information battery.
Yeah.
Okay.
I know, it sounds a little out there.
What does that even mean?
So instead of
Instead of like
storing energy in like
chemical bonds,
or by splitting atoms, but they want to store it in structured information patterns.
Like encoding energy into
the fabric of reality.
Yeah. So instead of like
your typical battery,
my lithium battery or whatever, they're talking about storing energy.
In information.
In information,
that's the idea.
How is that even possible?
They propose using another structured entanglement lattice.
Okay.
But this time it acts like a storage container for specific patterns of quantum information.
Okay, so imagine like a lattice of entangled particles all like vibrating.
In a specific pattern.
That represents stored energy.
And then the challenge is to control the release of that energy.
Okay.
And see if you can get it back out.
Without any loss.
And if they can pull that off.
That would be a game changer. For energy technology.
Imagine
zero fuel.
Energy system.
Powered by the controlled release of information-based energy.
Okay, I'm starting to see why.
This paper is causing a stir.
This paper is
a big deal. We've got potential anti-gravity. Faster than light communication. And information batteries.
This is a lot.
It's a lot to process, I know.
It is, but
it's not just about like new technology. It's about like
a whole new
way of understanding reality.
If information is truly fundamental, it changes everything.
Okay, so before we go any further, let's take a quick break.
Sounds good.
We'll be right back.
Yep.
To discuss those
mind-blowing concepts.
And what this new physics could mean.
Yeah, for our understanding of
everything.
Of consciousness and the universe itself.
Big questions.
I
know.
All right, see you in a minute.
Be right back.
Okay, so we've talked about the predictions and like all these crazy experiments. But what I'm really curious about is like the long-term vision. Like where does this all lead?
That's where it gets, really speculative.
Okay.
But also really exciting.
Okay.
They basically lay out this vision.
Okay.
For how this new understanding of information could lead to seriously transformative technologies.
Okay, give me the good stuff.
All right, so even in the short term,
if we could miniaturize the technology to control entanglement speed.
Okay, that could be huge.
For quantum networking.
Okay.
Imagine like communication systems that leverage those superluminal properties.
Superluminal, meaning?
Faster than light.
Okay.
To send information instantly.
Okay.
Across vast distances.
Whoa, okay. That's already pretty wild.
Yeah.
But what about further down the line?
So once we understand how to manipulate inertia using information, we could potentially see the first tests of like massless movement. Imagine vehicles that move without needing to push against anything.
So no more.
It would completely redefine
roads, no more traffic jams.
It's a whole new way of thinking about transportation.
Count me in.
Right.
But what about space travel?
Yeah, so...
Does the paper go there?
Absolutely. They say the ultimate goal.
Okay.
Would be full gravitational modulation.
What does that even mean?
Basically using information to...
Control gravity.
Control gravity itself.
So are we talking warp drives?
It's definitely...
Teleportation.
It's in the realm of possibility if we can manipulate space-time itself.
Using
information. Then the limitations of our current understanding of physics might not apply anymore.
So we could be talking about like traveling to distant stars in an instant.
It's a mind-boggling idea.
This is all.
It's a lot, I know.
A lot to digest.
Yeah.
Is there anything in the paper that like grounds this in reality?
Well, they do. They really emphasize the urgency of moving forward with these experiments.
Like now?
Like right now. Using the resources we already have.
So they're saying?
They specifically mention quantum optics labs for the entanglement speed testing and gravity labs with those like ultra-sensitive interferometers and quantum computing setups for the structured entanglement stuff.
So they're basically saying, hey, we have the tools. Let's start using them.
Exactly.
To unlock these mysteries.
Yeah.
It's a bold proposition.
It is.
But the potential payoff is so huge.
It's worth pursuing.
It's definitely worth pursuing.
Look at everything we've got.
This has been a total roller coaster.
I know, it's exciting stuff.
What stands out to you the most about all of this?
I think, for me, the most intriguing thing is this idea that information might be the fundamental building block
of reality.
It really challenges our assumptions about the nature of the universe.
Yeah.
And raises some profound questions.
Like about our place in it.
About our place in it, yeah.
It's funny, when we started talking about like information as this fundamental force I thought about, like computers and the internet.
Yeah.
But now it feels like
now it's like
we're talking about something
much bigger.
Something almost
like spiritual.
Yeah. I think you're onto something.
Yeah. Because for centuries we've separated the physical world
from the realm of consciousness.
But
this framework
suggests
they might be
interconnected.
Deeply interconnected, yeah.
So if information is shaping reality,
then our thoughts, our feelings,
our consciousness,
all forms of information
could have a real measurable impact
on the universe
around us.
So you're saying we're not just passive observers.
We're not just watching.
You're active participants. Shaping reality
with our mind.
With our minds. Yeah.
That's a lot of responsibility.
It is a lot of responsibility.
And it raises some questions about free will.
Free will, yeah.
Like, if our choices
are
ultimately expressions
of information.
Yeah, information. Are they
predetermined?
Or do we have the power to
or can we influence
the flow of information
to shape our own destiny?
And
maybe even the destiny.
Of the universe.
Okay, now my head is really spinning.
I know,
this is getting deep.
It is deep.
Yeah.
But I think that's part of the beauty of it. It opens up so many new avenues for exploration,
not just in
physics and technology, but in philosophy, spirituality,
and our understanding of
consciousness.
This deep dive has definitely left me with
more questions
than answers.
Yeah,
but in a good way.
I
feel like I've glimpsed a whole new world of possibilities.
It's exciting.
What about you?
What about me?
What's the one thing you hope our listener takes away from this conversation?
I think the most important thing is to remember that we're on the cusp of a scientific revolution. This information-centric view has the potential to answer
some of humanity's biggest questions.
The big ones, like where do we come from? What is the nature of reality?
What is our place in the cosmos?
Exactly. And it could lead to technological advancements
that we can't even imagine,
that we can barely even fathom.
It's a good reminder that the universe is still full of
mysteries, and the most mind-blowing discoveries
could be
right around the corner.
Okay, to our listener, I'd say
stay curious.
Keep asking questions.
And be open to the possibility
that everything we think we know
about reality
might be about to change.
Who knows what we might witness in our lifetimes.
Exactly. Okay, so we've been exploring this crazy idea, information shaping reality.
It's a big one.
Gravity, energy, even time. We've talked about the tech, like
the possibilities.
The crazy possibilities and the experiments to prove it all.
To see if it's really true.
But what does it all mean? What's the bigger picture here?
That's the question, isn't it?
It is.
The million-dollar question.
Yeah, and honestly, it's the part that
gets you thinking.
Gets me the most excited.
Yeah, because this framework, it's not just about new gadgets and gizmos. It's a whole new way of seeing the universe.
Our place in it.
And our place within it.
It's funny. When we started talking about information as this fundamental force.
This force,
I was thinking
about computers.
The internet.
Right. The obvious stuff.
But now, I don't know.
Now it feels
like we're talking about something
Like something
much bigger.
Almost
like spiritual.
Almost spiritual.
Yeah.
Yeah.
I think you're onto something.
I think so too, because for centuries we've kind of separated the physical world from the realm of consciousness.
Consciousness, like they're two separate things.
Totally different.
But this framework suggests
they might be.
They might be, like, interconnected.
Deeply interconnected, yeah.
So if information is really shaping reality,
then our thoughts, our feelings, our consciousness,
all forms of information.
It's all information. Yeah. It could have a measurable impact
on the universe.
Well, the universe around us.
So you're saying we're not just
passive observers. Just watching the universe unfold. We're active participants. We're shaping
reality
with our minds.
Yeah. Whoa, it's
a big responsibility.
A lot of responsibility.
It is.
And it makes you think about...
It raises questions about...
free will.
Free will, yeah.
Like if our choices...
are ultimately expressions of information.
Are they... I don't know.
Are they predetermined?
Or do we have the power to...
influence...
the flow of information.
To shape our own destiny.
And
maybe even...
the destiny of the universe.
Okay, now my head is really spinning.
It is a lot to take in.
Yeah, this is getting deep.
I think that's part of the beauty of it.
It's like it opens up
all these
new avenues.
Not just for
science,
but for philosophy, for spirituality.
For our understanding of ourselves.
Yeah, our understanding of consciousness.
Yeah.
This deep dive.
This one's been a wild ride.
It has. It's definitely left me with...
more questions.
More questions than answers.
That's how it always is with the really big ideas.
But in a good way.
It's
like I've glimpsed...
You've gotten a peek.
A whole new world.
A whole new world of possibilities. It's exciting.
What about you?
What about me?
What's like... The one thing you hope our listener
takes away from all this.
Takes away from this conversation.
I think the most important thing is to remember that we're on the edge of something.
A scientific revolution.
A scientific revolution.
This information-centric view, it has the potential to answer some of humanity's oldest questions. Like the big ones, like
where do we come?
What is reality?
What is our place in the universe?
We alone. All of that.
And it could lead to...
I think
technologies.
Technologies we can barely even imagine.
I mean, it's a good reminder that the universe...
is still full of mysteries.
And
the biggest discoveries... might be just around the corner.
So to our listener...
Yeah.
Stay curious. Keep asking questions. And be open to the possibility
that everything we think we know
about reality
might be about to change.
Yeah. Who knows what we might witness in our lifetimes.
It's an exciting time to be alive.
It is.
That's for sure.
Thanks for joining us for this deep dive.
My pleasure as always.
Until next time, keep exploring the mysteries of the universe.
And keep asking those big questions.